Hey, this is Mr. Beckstrom, and today I want to take a look at a problem from section 3.3. This has to deal with graphing quadratics, the parabola. And I wanted to do one straight from my math lab so we can use the actual graphing tool here. So here's the problem. It's -2 times x minus 4 quantity squared plus 8. So this is in the vertex form. The vertex form basically means that we can find the vertex pretty easily. So as long as it's in this form, the vertex is hk. Now one little trick that we use is if the formula has a minus in front, then when we're actually looking at the equation, we just take the opposite sign that's in front of that number. So if we go back over to the problem, we notice that it's a -4, so then we're going to use a +4 for our x value of the vertex, but this is plus k, so the 8 is going to be the y value. So it should be 4, 8. So go back over here, and my vertex is going to be 4, 8. So that's one point. Now notice something else is that this thing is going to open downwards. I know that because the A is negative. So if your A here is negative, then we're going to be opening down. Now in order to graph this, I'm going to need one other point. Now previously I had tried to put a 0 in here for x to find the y-intercept, but I found that the y-intercept turned out to be like -24, which wasn't on the graph, so we couldn't use that. So something else I can try to do here is I want to try to find some x value here that's going to make this quantity pretty small, so when I square it, it's not too big, and I get something a little bit easier. So I can either do 3 or 4 or 5 or anything like that. So let's do 5. So if I let x equal 5, remember all I'm trying to do is find another point. X equal 5. I'm just trying to find another point so I can use the graphing tool. Then if I put this back in here, y is equal to, my writing is not very good, -2, and I'll do 5 minus 4 quantity squared plus 8. So y is equal to 5 minus 4 is 1. 1 squared is 1. 1 times -2 is -2. And -2 plus 8 is +6. So y equals 6. So I know the point 5, 6 is also on our graph. And once again, I could have used 4. If I used 4, I would have got a 0. And I would have got 4, 8. If I could have used a 3. I think I would have gotten 3, 6 as well. So anything that's to make sure it's on the graph, we just need a second point for this. So 4, 8 is the vertex, and 5, 6 is a point. So going back, click to enlarge. And I'm going to do the parabola here. And first I'm going to do the vertex. So I'm going to go to 4, 8, put a point there. And next I'm going to do one other point. And we know that 5, 6 is on there. So I'll put that. And that should be all we need to do. And it is. Now the next thing it asks is the domain, and remember we've talked about the domain a few times. The domain says, is there any x value that I can put in here that makes this function either undefined or gives me back an imaginary number? And the answer is no. The only time we have restrictions is when we usually have either a radical or we have a quotient fraction, or, and I don't think we're going to be dealing with this much in this class, but sometimes when we're dealing with logarithms, we can do it as well there as well. So the domain here, since we don't have any restrictions, is just going to be from -infinity to +infinity with parentheses, because we never include infinity. All right, the next question is, what is the range? And the range, we really need to look at the graph in order to solve that one. And remember, we always start at negative infinity. Do we have values that are way down here because the range deals with the y values? The answer is yes, because these lines go down infinitely. So it looks like we're going to start at negative infinity, because that's we always start at the smallest values, negative infinity. But what's the highest y value? Well, the highest value y value is right here, and that's at y is equal to 8. So 8 would be our highest value. We put a bracket because we're including it, because there's an actual point there for 8. And that should be there for that one. All right, determine where the function is increasing and where it is decreasing. All right, so the function is increasing, so that's increasing means as we're moving from left to right. Where is our function going upwards? So moving left to right, well, it starts at negative infinity here. So because, remember, this goes down to negative infinity. So as we're moving left to right, this function is moving up. So that's increasing. So we're going to start at negative infinity. And it goes all the way until we get to what x value? It looks like 4. Right when we get to the x value of 4, this function stops. So we're going to put 4 in there, parentheses, because we're not including the 4, because right at 4, this function is neither increasing nor decreasing. And then for where is the function decreasing? Well, after it reaches 4, so we start at 4, remember we're always moving left to right, from 4 all the way to, and then as we go from 4 all the way to the right, this function is going down. So it's going to be to positive infinity there. All right, check the answer. And that's it. If you have any questions, let me know, and I hope you have a great rest of your day. Thanks.